So let's go ahead and look at this with a physical example. What we're going to start looking at is I'm going to set up a nice long spring that's really good at showing these waves. So it's going to be, I'm going to hold it nice and straight. And what I'm going to start doing is I'm going to put a single pulse through. So I'm going to just give it a single pulse so that this is going to move through the spring. Okay? We're going to be able to see how that works. The things that I want to pay attention to are how this pulse reflects back as this pulse travels over here. Let's use a different color to show that. When it hits the end and it reflects back, so when it hits the end here and has to reflect back, what happens? And then I'm also going to send two pulses down at the same time. And so I'll have a situation like this where we'll have a pulse here and a pulse here, and these are both traveling towards each other. What happens when they meet? I'll be able to slow the video down and we'll be able to look at that. And then the other thing is going to be when I've got a pulse going up and a pulse on the other side going down. And these are both traveling towards each other. What happens when those meet? So really, how does the energy move through this? So I want you to take note of just how these wave pulses move through the spring. And I really want you to remember what's traveling through the spring is energy. The physical spring, right, there's going to be a coil here. This part of the coil doesn't magically move over here. There is energy that's moving through, but this part of the coil just moves back and forth. So try and keep a lookout for those pieces that we just talked about, that amplitude, that wavelength, and that frequency. How quickly does the wave travel down? That would be the frequency. How long is that wave? That would be the wavelength. And how high, how big is that difference? So really, amplitude is going to be a way to think about how much does the spring actually move back and forth. Wavelength is really going to be this hump. How long is that hump? And the frequency is going to be how fast is that hump moving down the spring. So let's go ahead and take a look at it.
So here we're going to start looking at wave pulses. I just send one down the spring, and you can see that it just goes back and forth, reflecting back and forth along that spring. And the question is, what happens if I send two pulses at once? How do they interact with each other? So here I send two pulses at the same time, going in the same direction. So notice that when the first one reflects back, the pulses are on opposite sides of the spring. So when the two pulses meet, they're on opposite sides. So let's look at that in slow motion to see what happens when those two pulses meet. It's going to be pretty hard to see on this one, but for a split second, we can see that when these two pulses meet, they're canceling each other out. But what if they hit each other and they're on the same side? Let's try that. Can you see what's happening? Let's look at it again. So when the pulses were on opposite sides, they canceled each other out. But when they're on the same side, what's happening? Let's take a look at this one in slow motion too. When they meet on the same side, we can see that they combine to make one larger